Welcome back to Nexus Tech. You know, we always talk about the future like it's this slow drip gradually arriving. But what if it's not a drip? What if it's a tidal wave? Well, we think we've found the exact week where science hit the accelerator hard. We're going to break down an incredible 7 days in November 2025 where it felt like the future arrived all at once. So what if one week, just one single week, could actually alter our path forward? From the bizarre world of quantum mechanics to the very code of our DNA, the first week of November 2025 was just relentless. This wasn't a series of happy accidents. No, this felt different. It felt like a convergence. So today, we're going to connect the dots and show you how all these different pieces actually fit into one massive, mind-blowing puzzle. Okay, so let's get right into it. This isn't just a laundry list of cool headlines. The real story here is the feedback loop. Think about it. Brand new computers unlock secrets in our biology. Those biological insights then inspire us to create totally new materials. And those materials, well, they could redefine computing all over again. It's a chain reaction, and we're seeing it ignite right before our eyes. So here's how we're going to tackle this. First, we'll look at the groundbreaking new tools that are making all this possible. Then, we'll see how those tools are being used to literally hack our own biology and decode the universe itself. And then we're going to zoom out and ask, what does this insane pace of progress actually mean for all of us?
Every great leap forward needs a new kind of engine. And right now, the engine of discovery is computation. So that's where we have to start, with a machine that is fundamentally changing the rules of what is possible. Let's talk about Quantinuum's new Helios quantum computer.
Now look, these numbers aren't just theory from a white paper. This is the real deal. Helios is a commercially available system, and heavy hitters like BMW and JPMorganChase are already using it. And yeah, 98 physical qubits is impressive, but honestly, that's not the most important number on this screen. The numbers you really need to focus on are the fidelity scores.
And here it is. This is the number that is a total game changer. 99.921% 2-qubit fidelity. Now I know, that sounds like a tiny improvement, but in the quantum world, that is a canyon-sized leap in reliability. It means the machine makes far fewer errors, so you can actually trust its answers. And that is the key to unlocking problems we used to think were impossible.
So what exactly is fidelity? Well, the best way to think about it is signal quality. For decades, quantum computers have been incredibly noisy. It's like trying to listen to a radio station buried in static. You can't really make out the song. What Helios has done is basically invent the world's best noise-canceling headphones, allowing the beautiful, complex music of quantum computation to finally come through crystal clear.
And this is exactly why it's such a massive paradigm shift. Your laptop works with bits. They're either on or off, a 1 or a 0. Simple. But a qubit can be a 1, a 0, or both at the exact same time. It's that both that creates an exponential explosion in raw computing power. And with high-fidelity systems like Helios, that theoretical promise is finally becoming a practical reality.
So, you've just built one of the most powerful calculating machines in history. First question, what do you do with it? Well, you point it at one of the biggest, baddest problems in all of science. Researchers immediately used Helios to run the largest simulation ever of something called the Fermi-Hubbard model. Think of it as the mathematical rulebook for how electrons behave in materials. It's a critical step toward designing, from scratch, the holy grail, room temperature superconductors. The hunt is on.
Okay, so we have the new engines of discovery. Now, let's look at what happens when you apply these new tools and techniques to the most complex and personal machine we know of, the human body. Because in this very same week, we didn't just get one breakthrough, we got a masterclass in how to debug and reprogram our own health.
This is just brilliant. For a while now, we've known CRISPR therapy works for sickle cell disease, but we weren't 100% sure how. Well, now we know. It turns out it's not just about cutting DNA. Researchers figured out that CRISPR is being used to physically pry open a tightly wound up 3D ball of chromatin. It's like untying a microscopic knot. Once that knot is open, other proteins can rush in, shut down the bad gene, and flip the switch back on for the healthy fetal hemoglobin that we all carry. It's just elegant. It's biological engineering at its finest.
And then there's this. In another huge development, scientists found a critical weak spot in a very aggressive type of childhood leukemia. They discovered that a specific gene mutation creates this weird, abnormal handle on a protein. Another protein then grabs that handle and basically drags it to the wrong part of the cell, which is what triggers the cancer. By finding that handle, we can now design drugs to block it. It is a genuine Achilles heel for this devastating disease. And maybe the biggest of all, the Beacon Brain Atlas project dropped its first ever comprehensive map of the developing human brain, and the discoveries are just staggering. Turns out, our brains don't get built in neat, orderly stages, like building a house floor by floor. Instead, it's more like overlapping waves of different cells being created. This new ultra-high-resolution map lets us see the exact time windows where genetic risks for things like autism or schizophrenia might appear. It's even revealed brand new types of human cells we never knew existed.
And that's really the key takeaway. For so long, medicine has been about treating symptoms. This is about understanding origins. This brain atlas is the blueprint we've been missing. It provides the foundation to develop an entirely new generation of therapies, and maybe even preventative strategies for some of the most complex conditions out there.
All right, so from the inner space of the human brain, I want you to zoom all the way out with me to the cosmos. And then we're going to dive right back down into the unbelievably weird world of quantum materials. Because in the exact same week, we were getting postcards from other star systems and literally recreating the physics of a planet's core right here on Earth. Just look at this thing. On November 3rd, this comet was confirmed as only the third object we have ever seen visiting us from another star system. Think about that, a piece of another solar system right in our cosmic backyard. It screamed past the sun at over 150,000 miles an hour, and just a few days later, we got these incredible images of it blasting out these complex jets of gas and dust. This is an unbelievably rare chance to analyze the raw building blocks of another world. Okay, now let's come back to Earth, where another team was breaking a completely different kind of barrier. Researchers took a special alloy, and they squeezed it. I mean, they really squeezed it. They subjected it to 250 gigapascals of pressure. To put that in perspective, that is the pressure you would feel if you were standing at the dead center of the Earth. So why on earth would you do that? Well, you do it when you're chasing a scientific holy grail. Because under that crushing planet core pressure, their material became a superconductor at 25 degrees Celsius. That's room temperature. Now hold on, I know what you're thinking. You can't build a phone that requires the pressure of Earth's core. Of course not. But that's not the point. This is a monumental proof of concept. It proves without a shadow of a doubt that room temperature superconductivity is not science fiction. It is physically possible. The universe allows it. But see, finding one is only half the problem. To make them practical, we have to understand how they actually work. And at the exact same time, a totally separate team at MIT was digging into this bizarre material called twisted tri-layer graphene. And they were asking that fundamental question, what is the actual physics going on here? How are the electrons teaming up to flow with zero resistance? And what they found is just wild. In most conventional superconductors, electrons pair up indirectly. It's like two people jumping on a trampoline. They influence each other through the vibrations of the trampoline itself. But in this new graphene material, it's completely different. The electrons are pairing up by interacting directly with each other's own powerful electric forces. This is a fundamentally new type of superconductivity. It's like discovering a whole new chapter in the physics textbook. So let's just recap. We have quantum leaps in computing, biology, and physics, and this all happened in a single week. The future isn't just arriving anymore, it's accelerating. And understanding how all these fields connect is absolutely crucial to staying ahead of the curve. Listen, if you want to keep making sense of these world-changing developments as they happen, then do yourself a favor and subscribe to the Nexus Tech channel. We are here to break down the future for you every single week. So let's tie this all together. You have a new quantum computer powerful enough to help design new superconductors, a new understanding of physics that could lead to materials that power even better computers. And at the same time, we're creating biological maps that could help treat and even cure the diseases of the very minds that invent all these technologies. You see, it's not just progress anymore. It's a self-reinforcing cycle of innovation feeding innovation. Every discovery now makes the next one happen faster. That single week in November 2025 wasn't an anomaly. It was a preview. It was a glimpse of this feedback loop firing on all cylinders. The old, slow, linear pace of innovation is over. So the real question we have to ask ourselves isn't if the future is going to be different. The question is, how fast is it coming at us? If this is what 1 week looks like now, what does next year look like? Thanks for watching.